Further, we'll recapitulate the complex number in further details. We know that the complex number can be represented in real axis and the imaginary axis. We know that this is the imaginary axis. In the first quadrant, that both real and imaginary are positive, and as in the second quadrant, real is negative because it is in x coordinate, and imaginary is positive because in the y coordinate. Now exactly in the similarly third quadrant both are negative. In the fourth quadrant real is positive and the imaginary is negative. We know that. Now on the basis of it, you can see I have taken here I1. This is in the first quadrant, both are positive. Therefore we can find in the polar form, we can find the angle. Magnitude, this is the magnitude, 10 is the magnitude, and an angle is 53.1. And also we can very easily find in the rectangular form, as I told earlier. In the second quadrant you can see that your x coordinate, that means real is negative and the imaginary is positive. In that case, we know from the when we studied the complex number in mathematics, we know that this is minus 180 degree, 180 degree minus of tan inverse of that imaginary divided by the real. That means you can give the modulus sign here also, but if you keep the positive sign, and then modulus is not required. You can put a modulus sign. That means imaginary divided by the real. If you, again I repeat, if you keep only the positive, then you don't require imaginary. Then this is you can find it out, and that is the important thing here, to find the angle. And then after finding the angle, this will be in the polar form, then you can find the rectangular form. Exactly in the similarly third quadrant it is, this is tan inverse first, then minus of 180 degree. That is the difference, and that we studied actually in mathematics. I am recapitulating. Then this is in the polar forms, and that is in the rectangular form. And in the fourth quadrant, just it is a minus sign. This is a minus sign. That's all. That it is the minus, just like if first quadrant, but it will be negative. And this is I wanted to discuss so that we can recapitulate while solving the problems. And that is all about the complex numbers, complex representative of AC quantities. Now we'll see the power in AC circuit. The active power is given by this formula. VI, V is the voltage, I is the current, and cos phi is the power factor. And reactive power, that is VI sin phi, and apparent power is equal to voltage into current. Now another thing, if we ask to find out the power consumed, then it is the active power is the only it get consumed in the circuit. Therefore we have to apply VI into cos phi. Now we come to another important concept in AC fundamental, is that vector addition of two alternative quantities. Now we'll be discussing only the sinusoidal waveforms. Therefore let me consider there are two sinusoidal waveforms. One is expressed by I2 is sin Im2 and to sin omega t. Another is with a phase difference of phi. It is ahead of I2. I1 is ahead of I2. Now we want to sum this in vectorically. And how to do that? So first you can see that I1 is leading I2 by the angle phi. That is the one thing. Second thing, the I1 having the maximum as IM1 divided by root 2 is the RMS value that we discussed earlier. Therefore, here you can see I1 is the RMS value of the first sine wave, and it is the maximum divided by root 2. And this I1 is a vector quantities, but we do not give the sign symbol here. It is actually a vector quantity. And here also I2 exactly similarly, it is also a vector quantity when we give the phase difference. Therefore, this I2 will have a phase angle of 0 degree, and I1 it compared to I2 is the phase is leading by phi. Therefore, we represent it like this. Now, this I1 and I2 is a vector quantities. Now, we'll draw this. Therefore, I2, if we express I2, the length will be representing the magnitude, and angle will be thus. Angle will be represented by the reference line, how much it is. But we have taken I2 as the reference. Therefore, it is making the reference to the 0, 0. And therefore, I1 length is representing its magnitude, and the phi, it is leading I2, that leading I2. Therefore, this phi is representing its angle. Now, if we sum these two vector summations, I1 and I2, we'll get the I, and we'll get the I, and that is the vector summations of two sinusoidal quantities. Here you can see the I here, and the I1 and I2 has been vectorically summed, and the resultant is I. And here I am showing here. Therefore, these are two. All are the vectors. I is the RMS value of adding I1 and I2.